Laser is an optical device that produces electromagnetic radiation. In other words, it is a coherent light. Did you know that laser is an acronym? I bet you didn't. It actually stands for light amplification by stimulated emission of radiation. Now before I get into further detail, I would like to tell you how lasers are produced. Now, I will finally begin telling you how lasers are produced. One thing you should know is that it is the electrons in an atom which make a difference. Look at it this way, there are different energy levels in an atom that the electrons can be in. Picture it like this. The energy levels in an atom are like floors in a tall building. The electron can choose to be in whichever floor, depending on the amount of energy it has. Now, the most stable level is the one with the lowest energy, meaning that the electrons in the atom are in their lowest energy level. Occasionally, an electron might get excited to reach a higher energy state. The electron that got excited does not stay in that high energy level for long. It releases energy to return back to its low energy and stable state. The exciting part is when most of the electrons are in their excited state. Imagine all the office workers in a building wanting to take the elevator down at the same time. What happens with lasers is that we pump energy into the system and we end up with population inversion, where there are more excited electrons than low energy ones. The coolest thing happens when an excited electron starts releasing its energy. It starts communicating with another excited electron to release its energy too. The communication of the excited electrons to release their energy together is called stimulated emission. Overall, population inversion and stimulated emission lead to many electrons releasing energy at the same time, causing a chain reaction. However, there is a slight problem with that. All the electrons release energy in different directions, but by strategically placing mirrors within the laser, the energies will emit in the same direction. As photons bounce back and forth between mirrors, they communicate with more excited atoms in the material, causing more stimulated emission. Thus more energy is released as photons. So now we have three very important properties: population inversion, stimulated emission, and strategic planting of mirrors. From these three properties we give laser the following characteristics: monochromatic, coherent, and collimated. Monochromatic means that it consists of only one wavelength or color rather than different wavelengths. Meaning, if it was passed through a prism, it would not break into colors. Coherent means that all wavelengths are in phase, meaning all the crests and troughs are lined up. Collimated means all the light waves travel parallel to each other and in one direction. Thus, the light beams of a laser are very narrow and they can be concentrated on one spot.